All right, in this module, we're looking at recurring decimals to fractions. So we really want to turn something, a recurring decimal, which is something like 0.777 on and on and on forever. And we want to turn it into a fraction, so some number over another number. Like a half is a fraction, 3/4 is a fraction. We want some way to write this part here as some fraction. So we're going to say that point 0, so we want to write it so that some fraction is going to equal 0.0777 on and on and on. Now, rather than write this symbol here for a number we don't know or a fraction we don't know, we'll write this a little bit simpler and we'll use a little bit of algebra and we'll just call this part here our fraction that we don't know yet. We're going to call it x. So rather than write out a fraction looking thing, I'm just going to say x equals 0.777. It's a number, it's a fraction, we just don't know what it is yet, but we're going to use this to find it out. And there's a little bit of a trick to it. And the trick is that if this is x, then 10 times x, or 10x, would equal 7.77 on and on forever. Right, I just shift that decimal place one spot when I times something by 10. And that means that I can now do something a little bit tricky and get it so that, because to have a fraction, you've got to have just a whole number on the top and a whole number down the bottom. You can't have decimals involved. So what I'm actually going to do is I'm going to go 10x take x. So if this is 10x here and this is x, then that'll equal 10x is 7.77 on and on and on. And I'm going to take away 0.777 on and on and on. And really that's just going to like scrub out this part here, right? So all that is going to equal 10x take x will be equal to just 7. If I take this part here off this part, I'm just really getting rid of the repeating part, the recurring part. And this is my steps to solve. Now, if I've got 10 lots of x and I've got 1x and I take away 1x, then that leaves me with 9x equals 7. Now, if 9x's equals 7, and I want to work out just what 1x is, then I have to divide both sides by 9. And that will get me just one group of x equals 7 over 9. And see how I've turned it from a recurring decimal into a fraction. It turns out you can turn any recurring decimal into a fraction. So we'll do this now in a little bit of a trickier version. This time I'm going to turn 0.3636 on and on and on. And I'm going to write that as a fraction. So my first steps is I'm going to write it as some number over some number. So my first step is to say, well, let x equal 0.3636 on and on and on. Then 10x would be, so 10x would be equal to 3.636. That's not quite right, is it? Because I want to take away, I want to end up with a whole number, but if I take 0.36 off this part here, it's not going to work out for me. So anytime you've got two repeating numbers, you don't use 10x. We're going to see what 100x does for us. Now if I times 0.36 on and on by 100, that skips my decimal place 2 places. And I'll end up with 36.36 on and on and on. Starting to look a bit better. And then similar to what we did in the last step, now I go 100x take. So 100 lots of x take 1x will be equal to 36.36 take 0.36 on and on and on. That means that 100x take x will equal 36. Now I've got one whole number. Now if I've got 100 lots of x and I take away one lot of x, that'll get me 99 x's equals 36. And if I want to get the x by itself, if I've got 99 lots of x and I want to know what just one of them is worth, then I have to divide it into 99 parts on this side and divide this side by 99 as well. So it'll tell me that x is equal to These cancel out. Equals 36 on 99. If you had some number that was repeating 475, you would times it by 1,000 instead, but we don't have to do that for this one. Opens up.